National Electrical Code Section 408.22e enclosure for conductors states that where conductors enter a box, cabinet, or fitting, the provisions of 314.17 shall apply. Section 314.17 Access to boxes. Paragraph states that boxes shall be installed so that the wiring contained in them can be rendered accessible without removing any part of the building or structure or permanent part thereof, such as a cabinet, wall finish, or ceiling. Based on these code sections, you cannot run branch circuits in the same nipple as feeder cables. You must install a separate nipple for the branch circuits. The reasoning is that running branch circuits in the same nipple as feeder cables can create overcrowding, which can make it difficult to access and work on the conductors. Overcrowding can also increase the risk of damage to the conductors and the possibility of electrical hazards. Installing a separate nipple for the branch circuits ensures that they are accessible and code compliant. When dealing with electrical installations, it is imperative to adhere strictly to the National Electrical Code to ensure safety and compliance. The separation of branch circuits and feeder cables within a raceway or nipple is a specific requirement designed to prevent potential hazards and facilitate ease of maintenance and troubleshooting. Feeder cables are the main conductors that supply power from the source, such as the utility transformer or service equipment, to a distribution point within the building. These cables typically carry a substantial amount of current and are sized accordingly. Branch circuits, on the other hand, are the circuits that extend from the distribution point to individual loads such as lighting fixtures, receptacles, and appliances. They are typically smaller in size and carry less current than feeder cables. The National Electrical Code mandates the separation of branch circuits and feeder cables primarily for the following reasons. Firstly, accessibility is a key concern. When multiple circuits, including both feeders and branch circuits, are bundled together within a single raceway or nipple, it becomes exceedingly difficult to identify and access specific conductors for maintenance, testing, or troubleshooting purposes. In the event of a fault or other electrical issue, the confined space and the sheer number of conductors can significantly impede the ability to isolate and resolve the problem quickly and efficiently. Secondly, overcrowding is a significant factor. The National Electrical Code specifies the maximum number of conductors that can be installed within a particular size of raceway or conduit. This limitation is based on factors such as heat dissipation and the potential for physical damage to the conductors. When branch circuits are combined with feeder cables in the same nipple, it is highly likely that the raceway will exceed its full capacity, leading to overheating, insulation degradation, and an increased risk of electrical fires. Thirdly, conductor damage is a potential hazard. The close proximity of numerous conductors within a confined space increases the likelihood of physical damage due to abrasion, friction, or compression. Feeder cables, in particular, may be subjected to considerable stress and movement as they carry heavy loads, and this can exacerbate the risk of damage to the smaller branch circuit conductors. Any compromise to the insulation of the conductors can lead to short circuits, ground faults, and other dangerous conditions. Fourthly, electrical hazards are a significant concern. The mixing of branch circuits and feeder cables can create confusion and increase the risk of accidental contact with energized conductors. During maintenance or troubleshooting activities, it is essential to be able to clearly identify and isolate specific circuits. If branch circuits and feeder cables are intermingled, it becomes more difficult to ensure that the correct conductors are de-energized, potentially leading to electrical shock or electrocution. To ensure compliance with the National Electrical Code and to maintain a safe and reliable electrical system, it is essential to install separate nipples or raceways for branch circuits and feeder cables. This segregation allows for adequate spacing, easy identification, and safe access to each circuit. When installing a separate nipple for branch circuits, it is important to select the appropriate size and type of raceway to accommodate the number and size of conductors required. The raceway should be properly supported and secured to prevent sagging or damage. In addition, all conductors should be properly labeled and identified to facilitate future maintenance and troubleshooting. Consider the specific requirements of the National Electrical Code in your jurisdiction and consult with a qualified electrical contractor to ensure that your electrical installations are safe, code compliant, and reliable. Always prioritize safety and adhere to best practices when working with electrical systems. In addition to the National Electrical Code requirements, it is also important to consider the practical implications of combining branch circuits and feeder cables in the same nipple. From a maintenance perspective, it is far easier to troubleshoot and repair a system where the different types of circuits are kept separate. If a problem arises with a branch circuit, for example, it can be quickly isolated and repaired without having to disturb the feeder cables. This can save time and money in the long run, and it can also reduce the risk of further damage to the electrical system. Furthermore, separating branch circuits and feeder cables can make it easier to upgrade or expand the electrical system in the future. If additional branch circuits are needed, they can be easily added to a separate nipple without having to disrupt the existing feeder cables. This can be a significant advantage in commercial or industrial settings where the electrical needs of the building may change over time. Another important consideration is the potential for electromagnetic interference, also called EMI. Feeder cables, which carry large amounts of current, can generate electromagnetic fields that can interfere with the operation of sensitive electronic equipment connected to branch circuits. By separating the two types of circuits, the risk of EMI can be reduced. In conclusion, while it may seem more convenient or cost-effective to run branch circuits and feeder cables in the same nipple, it is not a recommended practice and is often a violation of the National Electrical Code. The potential risks and drawbacks associated with this approach far outweigh any perceived benefits. By separating the two types of circuits, you can ensure a safer, more reliable, and easier to maintain electrical system. Remember to always consult with a qualified electrician and adhere to all applicable codes and regulations when working with electrical systems. Safety should always be the top priority. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for safe electrical installations. It is developed and maintained by the National Fire Protection Association, or NFPA, and is widely adopted by jurisdictions throughout the United States. The NEC is not law itself, but it is often incorporated into state and local building codes, making it legally enforceable. The NEC covers a wide range of topics related to electrical safety, including wiring methods, overcurrent protection, grounding, and equipment installation. It is updated every 3 years to reflect the latest technological advancements and best practices in the electrical industry. Adherence to the NEC is essential for ensuring the safety of people and property from electrical hazards. Electrical installations that do not comply with the NEC can pose a significant risk of fire, shock, and other injuries. In addition to the specific requirements for separating branch circuits and feeder cables, the NEC also includes numerous other provisions that are relevant to the safe installation and operation of electrical systems. These provisions cover a wide range of topics, including conductor sizing, overcurrent protection, grounding, bonding, and equipment labeling. It is important for anyone working with electrical systems to be familiar with the NEC and to follow its guidelines carefully. The NEC is a complex document, and it can be difficult to understand and apply in all situations. Therefore, it is always a good idea to consult with a qualified electrician or electrical engineer if you have any questions or concerns about the NEC. The goal is to ensure that electrical installations are safe, code compliant, and reliable. In addition to the NEC, there may also be other applicable codes and regulations that apply to electrical installations in your jurisdiction. These may include state or local building codes, as well as codes and standards from other organizations, such as the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. It is important to be aware of all applicable codes and regulations and to follow them carefully when working with electrical systems. Failing to comply with these codes and regulations can result in fines, penalties, and even legal action. Furthermore, non-compliant electrical installations can pose a significant risk of fire, shock, and other injuries. For any work related to electrical systems, you should always consult with a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. They can also help you to understand and comply with all applicable codes and regulations. Attempting to perform electrical work without the proper training and experience can be dangerous and can lead to serious injury or even death. It is simply not worth the risk. Electrical systems are complex and potentially hazardous, and it is always best to leave electrical work to the professionals. Remember to always prioritize safety when working with electricity. Electricity can be dangerous, and it is important to take precautions to protect yourself from shock, electrocution, and other injuries. Some basic safety tips include always turning off the power before working on any electrical equipment, using insulated tools, and wearing appropriate personal protective equipment such as safety glasses and gloves. Also, it is crucial to never work on electrical equipment in wet or damp conditions. Water is a conductor of electricity, and it can greatly increase the risk of electric shock. By following these safety tips, you can significantly reduce the risk of electrical injuries. Regarding the specific question about running branch circuits and feeder cables in the same nipple, remember the reasons it is not recommended. Overcrowding, accessibility issues, potential damage to conductors, and heightened electrical hazards all contribute to the importance of separating these circuits. The National Electrical Code clearly addresses these concerns, and compliance with the code is essential for safety and reliability. By following the guidelines and consulting with qualified professionals, it is possible to ensure that electrical installations are safe, code compliant, and well maintained.